Namaste everyone. Today we are going to discuss about the electric charges and fields. I will take some parts of the introduction. Let us begin this chapter with a beautiful experiment. That is, you take a straw, this is available everywhere, and put a pin in the middle of the straw, and you make an arrangement for the other straw like this, and you can keep it over this straw and you can rotate it as you want. So this is a very simple arrangement that you can do in your house. Now take this straw and rub it against your fingers like this, on the same side like this. So 5 or 6 times you can rub it like this, and let your hands be dry, and it should not be wet, or it should not contain any amount of oil or so. Keep it over this straw and see here. Now you will find that the straw where you have rubbed gets attracted towards your fingers. Can you see the attraction here? So the fingers attract this straw. So this is one of the things that is observed in the ancient days. Okay. Now take another straw like this, same type of straw. Rub this also. Now you see a beautiful result. So rub this straw against the same hands and bring this straw very close to this. Can you see the repulsion? So there is a beautiful repulsion between the two. You can do this experiment in your house. You can try this in your house, and no expense is needed. You will get straw everywhere, plastic straw. So there is a repulsion. So this is a common thing that we observe in our day-to-day life. And another common thing that you see that in your school, if you are called to the auditorium for any function, you go and sit in a plastic chair. And as soon as you sit in a plastic chair, you find that your hairs get attracted towards the plastic chair and hairs become very straight. This is a very great experience, again another one. So in this way people started experiencing many things. In the ancient days, it was Thales of Miletus, and this person in 600 BC he observed that amber, you don't know what is amber? So most of you may not have heard this word, that is amber. Amber means the type of gum that you get out of a plant when it is wounded. When you just disturb some part of a plant, some type of liquid comes out of it, and when it gets solidified, it becomes transparent like this, and that is called amber. And biologists find this very interesting, because if some insects or some other creatures get deposited inside this, that is a very good deposition, and it is a preserved object, and it can be preserved as it is for long and long years. And biologists study this, insects and other things preserved inside this amber. So when this amber was rubbed against wool or feathers, they started attracting each other. Feather got attracted towards this amber when they are rubbed against each other. And this experiment was done by Thales of Miletus for the first time in 600 BC, long back. So this gave a very interesting feature. Why this is happening so? Why the hairs get attracted towards this plastic chair? And what has happened to this? And every time this doesn't happen. And in the olden days, there was a TV which is a CRT TV, cathode ray tube TV. When that TV is made to switch on, and after switching off, if you bring your hands near the TV screen, you will find that the hairs get straightened. And all these factors made the man to think about what is happening around nature and why these things. And another interesting experiment, again you can observe this in, you can do this in your house, and I have some paper pieces. I don't know whether this works very well or not. You take some cotton or wool, wool is the best choice, and a comb, plastic comb. Rub the comb against this cotton or wool many a times, rub it thoroughly like this, and after rubbing you bring the comb near the paper pieces, and paper pieces should get attracted. Now this is not working properly, there may be some moisture or something. If there is moisture, this doesn't work. Okay, let me try again. Yeah, some of the paper pieces get attracted towards this one, you can see that little bit. So you can try this also, or you can comb your dry hair using a comb, plastic comb, thoroughly, and then bring it near the small paper pieces. The paper pieces get attracted. So this is also one of the interesting features that you see in your day-to-day life. So charges come into picture in many places in our life. Let me try it once again. Right? You should have a wool cloth, then it works very well. Yeah, little bit of attraction you can see here. The paper pieces get attracted towards this comb. So what is the problem here then? What has happened here? This is a very interesting factor, and these are all come under static charges. And we study electrostatics, we call electrostatics. Static means, you know, it is one which is at rest, which is not moving with respect to a frame. So electrostatics deals with charges at rest, charges which are not moving. When the charges move, the whole story changes, and you will have to study it in a different chapter called current electricity. So now we will see what is these electric charges and fields, and what is the reason for the straw getting attracted towards the fingers when you rub it against your fingers. What is the reason for straw repelling another straw when they are brought together, both are rubbed against the hands? The reason can be studied like this. Suppose you look into the structure of a material. All of you know how an atom is made up of and all. Every material is made up of molecules, and molecules are made up of atoms. How is the model of the atom? In an atom, we have a nucleus, and usually we say nucleus is positively charged. Why? Because nucleus contains two members. One is neutron, another is proton. Neutron is electrically neutral, and basically it is like that. And proton is having some charge. And we conventionally give positive charge for the proton. That's why nucleus is positively charged. And where are electrons? Electrons are revolving around the nucleus in definite orbits. And here is an electron revolving around the nucleus, and another electron will be revolving around the nucleus in another orbit like this. So electrons will be choosing different orbits to revolve around the nucleus like this. And we give negative charge for the electron. Why negative and positive? We will see that. Now, so you ask these electrons. You ask the first electron. I will name the electrons 1, 2, 3 like this. Ask the electron 1. Electron 1, electron 1, can you come outside? I want to have some work with you. Electron 1 doesn't come. Oh, no, I can't come. Why? Because I am tightly bound to the nucleus, and I am very busy. And if you want me to come out, you must supply me large amount of energy, and small amount of energy is not enough. So it's very difficult to remove an electron which is in the innermost orbit, and it can't come easily outside. You ask the last electron in the outermost orbit. It is very far away from the nucleus, and it is very less bound to the nucleus because the distance is more. And you ask electron 3. Electron 3, can you come along with me? Electron 3 says, I'm revolving around the nucleus, but my bond with the nucleus is very less. I'm tightly bound to the nucleus. And I'm weakly bound to the nucleus. And if you want to remove me, give me some amount of energy. In any form, I will come out. It is these electrons which get transferred. So why these electrons are given negative charge, and why these protons are given positive charge, and why neutrons are given neutral charge? That means they don't possess any charge. Basically, particles, these elementary particles, what we call the basic particles which are used to build up the material, they are having some physical properties. As if human beings are having some physical properties, like somebody get angry very quickly. You ask them and go and ask them, why are you getting angry? It's by nature itself. He has tried in his life many a times to control it, but by nature himself, he is like that. Some people are very cool, whatever may happen, whatever be the situation, they are very cool. By nature themselves are like that. Similarly, electrons, by nature, they have that physical property called charge. They have a nature. Protons have, by nature itself, they have that property. Neutrons don't have. Neutrons are electrically neutral. As a whole, atom is electrically neutral, remember. And atom is having no charge because we have equal amount of positive and negative charge. Sir, why this positive and negative? Why can't you call it as yes or no, true or false? And who just started these all conventions? Remember all these positive, negative, and electron is negatively charged, proton is positively charged. All these are conventional, and there is no derivation, there is no proof for that. We are conventionally we are following it. For example, you are driving your vehicle on the left side of the road. Who told you to do that? There is a conventional rule that we did like this. And is there any derivation to say that driving in left side is a perfect form? No, nothing like that. You can drive in right side. In America, people drive in right side of the road. But all the people should follow the same rule. That is convention. Now, when you rub a straw against your fingers, straw and fingers get attracted. When you rub a straw, another straw, and bring this straw to nearer to this, they get repelled. So there should be two kinds of charges. You find two types of activities, one attraction, another repulsion. So Benjamin Franklin, and you can see him, American thinker, he is everything, American thinker, American politician, and scientist, and all in one. And he has contributed to the Constitution of America. So that's why America has printed in $100 currency his photo here. This Benjamin Franklin thought that when there is attraction and repulsion, there should be two kinds of charges. Now, how to name them? Shall we name it as positive and negative? Yes or no? True or false? Or something else? Best choice is positive and negative. So he named it as positive and negative. So this may be a one mark question. Who named charges as positive and negative? It is Benjamin Franklin. So you have seen him, right? This is Benjamin Franklin. And you can see his photo in $100 note in currency in America. Okay. So we will take the charges as positive and negative. Now, which is positive and which is negative? We can do experiment like this. You can have many experiments like this. You see, for example, you can rub fur with the ebonite rod, and you can rub cat fur with the plastic rod, and glass rod with silk, wool with plastic rod, and you can rub your hands with the this plastic straw. So one gets positively charged, another gets negatively charged. That's why there is an attraction. Which is positive and which is negatively charged? Again, by convention. We have to take something as positive, something as negative, basically, and we should start building up that this is positive and this is negative. So something should be taken reference. Electrons are given negative charge. This is purely conventional. And if electrons are given negative, you can't give negative charge for protons, because electrons and protons attract each other. So proton should be given the opposite charge, that is positive. So conventionally, charge of an electron is taken as negative and charge of a proton is taken as positive. So this is also pure conventional. There is no particular story behind it. So now what are the charges? What is the amount of charge that you have in electron and proton? The symbol may be negative or positive. In order to identify that they are in opposite nature, what is the value? The charge of electron was experimentally verified, and I will take it as E, and I don't write that it is negative and positive. I will simply write it as its magnitude value. The magnitude of charge of electron or proton is 1.602 into 10 to the power minus 19. C I will write. What is C? C is Coulomb. SI unit of charge is Coulomb. We will get it later. Why it is Coulomb, and how do you define 1 Coulomb? How much Coulomb is the charge of a body and all. So charge of electron or proton magnitude wise is 1.602 into 10 to the power minus 19 Coulomb. Right. Now electrons are given charge minus 1.602 into 10 to the power minus 19 coulombs, and protons are given charge. Each proton will be given plus 1.602 into 10 to the power minus 19 coulombs. So that is the story behind it. Now you have asked the electron 1 to come out. Electron 1 did agree that I will come out because it needs a lot of energy to come out. It is as if you are pulling your friend who is inside the well, deep inside the well. It is very difficult to pull him out. So this needs lot amount of positive energy to remove. Whereas here, electron 3, the outermost electron is ready to come. Give me small amount of energy, I will come. That is what happened when I rub straw against my fingers, when I rub this comb against your cloth. Everything happens like this. Basically, every atom is neutral. We will take some odd numbers so that it becomes very convenient for our day-to-day life, but in reality it is not so. Let us assume that there are 100 protons inside the nucleus. There are not 100, there are plenty of protons inside the nucleus. Equally, 100 electrons will be revolving around the nucleus. So inside the nucleus, if you have 100 protons, definitely there are 100 electrons outside the nucleus, so that atom as a whole is electrically neutral. So if atom is neutral, that doesn't mean that there are no charges inside. There are charges, but there are balanced charges. So all the charges are balanced. So 100 protons, 100 electrons. Very odd number I have taken. It is not in reality. A number is very large. Large number of protons and electrons you will have. Now, out of those electrons, and all protons will be very safe inside, like they are going for a quarantine. They don't come out. They are sitting very strictly following the quarantine rules, and they are sitting inside the nucleus. What about electrons revolving around the nucleus? Now, Out of those electrons, some are very busy in revolving around, they don't come out, and they need a lot amount of energy if they want to come out. And outermost electrons are very loosely bound. You can give some amount of energy and you can remove them. Now suppose I rub my fingers against this straw, or a comb against a cloth, or a glass rod against some wool, something like that. Then what happens? These outermost electrons, they leave the body. They come to the other body when I rub them against each other. So when outermost electrons are moving from one object to another, what happens is total charge is imbalanced. Imagine that I have two objects, object A and object B. I rub them against each other. Originally this was having 100 electrons and 100 protons, say. And say this is also having 100 electrons and 100 protons. And this example is just only for understanding purpose, not for examination. Just you should have a knowledge how it is getting charged. Now, because these numbers are very odd numbers. Okay, now, after rubbing, suppose 10 electrons move from A to B. Sir, why it is only from A to B? Why not from B to A? Okay, B to A is also possible. In a material where the electrons are most loosely bound, from that material electrons are transferred to the other material. In a tug of war, the team which is very little weak will lose the game. Similarly, in which electrons are loosely bound, they get transferred to the other body after rubbing. Because rubbing gives a lot of energy, it produces heat, supplies energy to the other material. Using that energy, electrons get transferred to the other one. Now what is the attendance now? Attendance is you have 100 protons. Protons are in 100 number, no doubt, because they don't live. They are very safe inside the nucleus. It is very difficult to remove protons. Protons don't move at all so easily. By rubbing, you can't remove protons. Okay, what about electrons? Has lost 10 electrons, so 90 electrons. And what about here? You have 100 protons, not lost. Gained 10 electrons, so 110 electrons. Now if you see that, the imbalance has created. And 90 electrons can neutralize 90 protons. There may be total neutralization. But what about 10 protons? They are excess in number. So you have 10 protons excess. So this body gets positively charged. One which loses electrons gets positively charged because number of protons have increased. What about here? This body, body B. Body B has gained electrons. So its new number will be, and here you have 10 electrons excess. Okay? 100 electrons have neutralized 100 protons. But there are extra 10 electrons, so this gets negatively charged. This is how a body gets charged. So automatically, when I rub my fingers against the straw, my fingers might have lost electrons, maybe positively charged. Straw might have got electrons, maybe negatively charged. So there is an attraction. So here what we have to conclude is, a body which loses electrons gets positively charged, and the body which gains electrons gets negatively charged. And how much charged, that depends on how many electrons are lost and gained. So this is the important factor, and nowadays we know why the materials get charged. And another important thing is, when I rubbed the comb against that cloth and brought it near the paper pieces, there was attraction. But I didn't charge paper pieces. So there was an attraction between uncharged paper pieces and charged comb, plastic comb. So a charged body may attract uncharged body also. So if you go on writing the properties of charges, you can easily write it like this. I will cover the properties of charges one by one. So you have found that positive and negative charges attract. And Benjamin Franklin named it as there should be two kinds of charges. One is named as positive, another is negative. So I will call positive as like charges, negative as like charges, positive negative as unlike charges. So like charges, plus minus, they repel. So I can write first property, like charges repel and unlike charges attract. Right? So positive and positive charges repel, they are like charges. Negative and negative charges repel, they are like charges. Like means similar. Whereas unlike charges, opposite kinds of charges, plus and minus, attract. This may be the first conclusion that we can see. One which has lost electrons gets positively charged, and one which has gained electrons gets negatively charged. They attract because they become unlike charges. This is the first property. And another property of charges, I will cover one by one like this. Let it be here. Right? Now, when you charge a body, you know how to charge a body now. What is the method of charging a body? You must go and request electrons. There is no other way. You can't request protons. You have to request some electrons to move from one body to another. So you can charge a body. There is no other way because protons cannot be removed so easily from the nucleus. So what is the amount of charge that is gained or lost from a body? We will write the charge of an electron or a proton, magnitude of charge here. Let it be here because it is needed. And you have to remember this value always. It's needed for the exam, and this value will not be given. So magnitude of charge of electron or proton is 1.602 into 10 to the power minus 19 coulomb. See how small it is. Very small, because you have your 10 to the power minus 19. So you will have 0.000, 18 zeros and 1602. So much small value. But let it be. Now if you want to write how much is the charge gained or lost, body A, say, has lost 10 electrons to body B. It has lost 10 electrons to body B. Now, these 10 electrons are having a deficiency here. They create a deficiency here, and that will be excessive number. And what is the charge gained by both? This will be positive, this will be negative. And how much? You have to add the charges of 10 electrons. Because 10 electrons are here, and 10 electrons lost here. So 10 times is the basic charge. So basic charge is the charge of electron. So if I write the amount of charge, it is as if you buy mangoes. Suppose one mango weighs some 50 grams, say. One mango is, small mango is 50 grams. And if you have 10 mangoes in your bag, how do you calculate what is the total mass in the bag? It is 10 into 50 and 500 grams. Similarly, if 10 electrons are transferred, Q is the symbol used to represent charge. So from here onwards, we restrict Q to the amount of charge on a body, either capital Q or small q. So shall I write Q is equal to NE, where number of electrons transferred from one body to another and charge of each, the magnitude of charge of each electron. Now, what is N? N can stand, and here you can have the values plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, so on, like this. Sir, why only integers? Charge is always quantized. Electron charge is always quantized. This is another property. Charge is quantized. What do you mean by quantization of charges? It should be only in the form of integers. Electron is the basic building block, one of the basic elementary particle. It has that physical property called charge, which is negative, which we conventionally take it. Now, electrons are not made up of any other elementary particles. That you have to remember. Electron is an electron. Whereas on the other hand, if you take a proton, proton is made up of some other basic elementary particles like quarks. But electron is not made up of such elements. Electron is electron, and it is not made up of some other basic particles. So if you want to add electrons, or if you want to remove electrons from a body, you have to add or remove it in the form of numbers only. For example, if you want to count the number of friends in your class, how do you count the number of students in your class? You stand up and count 1, 2, 3, 4 like this. Every person is given a single digit. And you don't count 1, 1.5, 2.33, 5.33, because how do you count 0.33 for a person? A person is taken as a single number. And if you go to a shop to buy the balls, how do you ask the shopkeeper? You will go and ask the shopkeeper, give me 3 balls, give me 5 balls, give me 2 balls. You don't ask him, give me 2.56 balls. Because fraction balls purchasing has no meaning in our day-to-day life. And immediately if you ask him to give me 2.33 balls, he will look at you. From where did you come? What is your problem? He will suggest you to consult a doctor, because fraction of balls doesn't exist. Similarly, fraction electron doesn't exist. Charge, this is the single charge, and you can't make it a fraction. You can add it in whole numbers. So if a body has lost electrons, and if a body has gained electrons, and the number of electrons gained and lost must be an integer form. It cannot be a fraction at all. That's why you can substitute here either 1, 100, 50, 42,000 and so many crores, that cannot be a fraction. So that's why I have given. Sir, why plus or minus 1, plus or minus 2, plus or minus 3? Suppose a body loses electrons, you take plus 1, plus 2, plus 3, plus 4. If it gains electrons, then give minus 1, minus 2, minus 3, minus 4. That's all. So n can take these values. Now we will come back to this problem. So that is why the quantization of charges. Suppose you are asked to write the properties in the exam. Write 3 properties of charges. Sometimes you get for 3 marks, very easy question. 3 points, writing, saving some time, getting full 3 marks, no doubt here. So you have to select such type of questions which are in points form. Just writing the points and getting the full marks. You can save a lot amount of time. So if you are asked to write what are the properties of charges, just write charge is quantized. Enough. Suppose you are asked to write, or if you are asked with the question, what do you mean by quantization of charges? That's a different one. You have to explain what is quantization. Quantization of charge means it is like this. Charge on a body must be equal to always an integral multiple of charge of magnitude of charge of electron, or elementary charge. Elementary charge is this one. So charge on any body is equal to the integral multiple of the basic charge, that is charge of an electron, magnitude of charge of electron. That is called quantization of charge. It cannot be other than an integer. It cannot be a fraction. So if you are asked to write the property, simply write charge is quantized. What do you mean by quantization of charges? Charge on a body is an integral multiple of charge of basic charge of electron or magnitude of charge of electron, and you can write the formula also if you are asked to explain it, and write what is n equal to. So this is one of the property, very important property. Charge is quantized, and suppose there is one more question. What is the minimum amount of charge you can transfer from one body to another? What is the minimum amount? And minimum amount should be this one. What is the minimum number of balls you can purchase from a shop? Is it 0.5? Is it 0.3? No, it is 1. So when you put 1 here, Q equal to E, that is this one. So the minimum amount of charge that can be transferred from one body to another is the charge, magnitude of charge of electron. Okay, that can be another 1 mark question. Okay, and who named charges as positive and negative? Again, that may be a very important question. Again, Benjamin Franklin. And who, for the first time in the history, said that amber, when it is rubbed with wool, they get attracted. It is Thales of Miletus. And okay, now we will come back to the properties again. We will see third one. So you can calculate this one. This is in half a now. Q is equal to, suppose 10 electrons are transferred, 10 into 1.602 into 10 to the power minus 19. This is the charge gained by these bodies. And I can use this 10 for this one, right? I will ask this 10 to make a friendship with the 10 to the power minus 19. What will be the answer then? 1.602 into 10 to the power minus 18 coulombs. Here you have 10 to the power 1, and here you have 10 to the power minus 19, so minus 18 coulomb again. SI unit of charge is coulomb. We will see what is 1 coulomb. Okay. Now, if you want to write another property of charge, charge is conserved. What do you mean by conservation of charges? This is another very, very important property of charge. Charge is always conserved. Now in first year we write, and even in your lower classes you have studied, energy is conserved. As soon as you get energy is conserved, automatically another sentence comes into the picture there. Energy can neither be created nor be destroyed. It is like Jack and Jill went up the hill. It comes along with that. So what do you mean by conservation of energy? Energy can neither be created nor be destroyed, and it can be only transferred from one form to another. But that is not so in the case of charges. You can't say charges can neither be created nor be destroyed. That is completely wrong, and that is not the explanation for the conservation of charges. Charges can be created. You will study in modern physics later on that when gamma rays enter the Earth atmosphere under suitable conditions, gamma ray, which is nothing but a packet of energy, just gets converted into two charged particles called positron and electron. So you can create charges, but of course the pair created there is one positive and negative, and total it is neutral, but still you can't say charges can neither be created nor be destroyed. That is not the case. Then what about conservation of charges? Now if you do see this experiment, you know that this was containing 100 electrons, 100 protons. This was also containing 100 electrons and 100 protons. Simply taken that number. If you take the total, after this losing, this body A losing electrons, they are found here. So within that system, within that experiment, you find that the total number is same. Only imbalance have been created by transferring the electrons from one body to another. It is as if you have a balanced balance in which there are 10 mangoes here, 10 mangoes here. Both are balanced now. You remove one mango from here and put it in the other pan of the balance. Then the balance becomes like this, because the right side will have 11 mangoes and the left side will have 9 mangoes. So there is a difference. But what about the total mangoes? It is same. That is the meaning here. So if this has lost electrons, this has gained electrons, same number of electrons, total number of charges remain the same. Again, it is neutral. System as a whole is neutral. A might have got positively charged, a B might have negatively charged, but total system is neutral. That is what you have to explain. Now if you are asked to write the property, simply write charge is conserved. Enough. What do you mean by conservation of charges? Then you have to answer in a different way. Total charge in an isolated system. What do you mean by isolated system? A system in which something is happening and it has no relation with the other outside system. We are concentrating only on these two bodies. Total charge in an isolated system is always conserved. That's what the explanation you have to write. So what do you mean by conservation of charge? Total charge in an isolated system is always constant, or total charge in an isolated system always remains constant. So very important property. And the fourth property, of course you can interchange the numbers. Now as the flow comes, I will go on writing it. Another important, very easy, charge. Now try to think of charge is, can it be a scalar or a vector? Charge has no direction. It has only magnitude, like mass. And so charge is a scalar quantity. It has no direction. Charges are scalar quantities. That is also one of the property. And fifth one I'll write. Charge is additive in nature. Charges are additive in nature. What do you mean by charges are additive in nature? Just we have seen here, when 10 electrons are transferred from here to here, what is the charge of this? This charge of this is the charge of 10 electrons. That means you have to add this charge 10 times and give a negative sign. For this one, negative sign, and this one, positive sign. That's all. That means you can add the charges. So if you have a system like this, and if this body is Q1, having a charge Q1, and if this body is having a charge Q2, and if this body is having a charge Q3, what is the, or I will give you minus Q3. What is the total charge on the system? Total charge on the system is Q is equal to Q1 plus Q2 plus here it is a minus Q3. Or you can take it as plus Q3 and you can write plus Q3 also. So charges are additive in nature. If you are asked to write the property, write only that much. Charges are additive or additive in nature. What do you mean by that? Suppose Q1, Q2, Q3 are the charges in a system, then the total charge is Q1 plus Q2 plus Q3. Or if you give a minus sign to one of them, Q1 plus Q2 minus Q3 you can write. So you can add them. Add means subtraction is also one type of addition. Okay, so that is another property. Okay, now we will see few more things about the charges. Okay, we have seen how to charge a body. So one method is friction. You can rub them against each other, and electrons get transferred. Remember, it is not protons. Electrons get transferred from one body to another, so they get charged. One which loses electrons gets positively charged, and one which gains electrons gets negatively charged. Okay. Now, according to the type of electrons available, we classify the materials. You know this one. One is a conductor, and I will take only conductor and insulator. What are these? How do you differentiate? How do you name them? And why do you differentiate them like this? What are conductors and insulators? You know the examples also. In your day-to-day life, you come across this many a times. Conductors like metals. All metals are good conductors. Gold, silver is the best conductor, and iron, copper, aluminum, they are all conductors. Even human body is a conductor. Earth is a very good conductor. Now, what are insulators? Glass, plastic, dry wood, not living tree is not a insulator, it may be a conductor. So dry wood, plastic, glass, all cotton, they are all insulators. Sir, why they are differentiated like this? If you try to pass electricity through wood, it doesn't allow the electricity to pass through. Whereas if you see a copper wire, it allows the electricity to pass through. What do you mean by that? So if the charges can flow through a material, then it is called a conductor. If a material doesn't allow the charges to flow through, then it is called an insulator. Now why do they do so? Very simple. We have seen in one of the diagram that atom is positively charged because of protons, and it is very strong, and it is held at the center. Electrons are revolving around the nucleus, and that is like a structure, and we call it as an atom. And now among these electrons in metals, there are some other electrons. You call one electron and ask in a metal, say copper, how are you, what are you doing? Electron says, I am revolving around the nucleus. Okay, you go and do your job. Ask another electrons. There are plenty of electrons which are neither revolving around the nucleus nor taking part in any bond, but simply moving inside the metal from atom to atom. They are not keeping on revolving around the nucleus. And these electrons are called free electrons, and these electrons are found large in number. Free electrons in metals only. There are no free electrons in insulators. Remember, I didn't say there are no electrons in insulators. There are electrons, but they are not free. It is as if some students in a college or school are tightly bound inside the class because class is going on, and they are afraid of teachers. So they are simply sitting and listening to the class. They are bound electrons, and some students will be moving in the corridor from classroom to classroom, and they will be looking into the students who are listening to the class. So they are free electrons. They are neither sitting in any class nor going to the library, simply going here and there. They don't have any job. And similarly in metals, in conductors, we have plenty of free electrons, and these electrons will be moving inside the material here and there. Such type of free electrons are not found in insulators. There are electrons which are revolving around. They are busy. They are not free. So when you take a metal and connect a battery, we call it as applying potential difference, and you are going to study this in your later chapters. When you do so, current flows through the metal. What do you mean by current? That is the flow of these charges. And flow of these free electrons in a metal, of course there are different types of free charges. In metals, flow of free electrons makes current. And remember, you may be defining this in the later chapter, that current is equal to rate of flow of charges, right? dq by dt. And current is also a scalar because it is a flow of charges. So current is also a scalar quantity, right? So these free electrons are plenty in number in conductors, whereas in insulators there are no free electrons. That's why we say conductors allow the charges to flow through, insulators do not allow the charges to flow through, and we say it in this way also. Conductors allow the flow of electricity, and insulators don't allow the electricity to flow through. So that's how we differentiate this. So there are no free electrons here. So no free electrons I can write. I don't write no electrons, no free electrons. All the electrons are busy. They say, I don't come, I don't have free time, and I am busy in revolving around the nucleus, so I can't make the current to flow through. So all the electrons are busy in insulators. Okay. Now, methods of charging a body. This is another important part. Methods of charging a body. How can you charge? And because you have two types of materials now. How can you charge an insulator? How can you charge a conductor? So plastic is an insulator, remember. One thing we have seen, rubbing. Rubbing the two things against each other. When you mechanically rub the two things each other, mechanical energy is converted into heat energy. That energy gained by the electrons will come out. So that will share the electrons from one body to another. So that gets charged. So we call it by friction. Friction is the method of charging a body. One method. Rub the things against each other. But remember, in friction, you can charge insulators. Insulators can be charged by friction. So I need not explain it in detail again. Take the two insulators, rub them against each other, electrons get transferred, and those electrons which are in the outermost orbit, which are loosely bound, they get transferred from one material to another. So one which has lost electrons gets positively charged, one which has gained electrons gets negatively charged. So that is one thing. So but you can't do this with the other materials, only insulators can be charged by friction. Second one, conduction. Okay. Conduction, you know, conductor, and conduction, allowing, right? Conduction, and the third one process is induction. So the three processes here of charging a body is conduction, induction, and friction. We will see what it is. Only metals or conductors can be charged using this method. Insulator cannot be charged by using this method, because if induction and conduction has to occur, it should be a material which can allow the charges to flow through. But unfortunately, insulators don't allow the charges to flow through. So you can't charge an insulator using these two properties, or by using these two methods, because of the property of the insulator. An insulator can be charged only by friction. So maybe one more question. Name the method in which an insulator can be charged. It is only friction. Name the method in which a metal or a conductor can be charged, either conduction or induction. Let us see how to go for this one. This one already we have discussed. Okay. I'll rub this now for the time being. Right. Conduction, very simple. If you want to charge a conductor, say I have a spherical ball, copper ball, I want to charge it. So how to charge that conductor? It's a conductor, it allows the charges to flow through. It is as if I have an empty beaker like this. I have an empty beaker, and I have a beaker filled with water. And this is not charged, this is charged. Now I want this water, some amount of water to flow through this. What you can do? Water has the property of conducting, that means flowing. So I can open this, connect it by a pipe, water flows from here to here till the levels are same. So till the levels are same like this, the water flows from this to this. So this is also charged now, this is also having water now. Now how to charge electrically? Electrical charge. Okay. I'll take a conductor which is already charged. I'll take a spherical conductor. Say this is positively charged. Or I will take electrons only. That is easier for explanation now. We will see how the positive charges get distributed later. I'll take negatively charged body. Now how this was negatively charged? Somebody might have given electrons to that conductor. So this has received electrons. Now I have another identical conductor. Of course, this spherical conductor or spherical ball are made up of metal, may not be of the same size as this one. I'll name them A and B. May not be of the same size, may be smaller, may be larger, whatever it is. Now this is a conductor, this is a conductor. So connect them by a wire. I can connect them by a wire or bring them in contact, make them to touch each other. Now when they are brought in contact, you see this one. One property I have to explain here. In a conductor, charges always come to the outside part. They always reside on the outside surface of a conductor. Now for example, if you take a spherical ball, say shell, a spherical shell, inside it is hollow and it is made up of metal, and I put some electrons inside. I make a small hole and I will take a very small stick and charge it, and I put these charges here inside. Now will they stay inside? This is another property of charge. Charges always reside on the outer surface. Sir, why do they come outside this spherical conductor? Very simple. Electrons repel electrons. Like charges repel. So when you put two electrons over a conductor, definitely these two electrons will start repelling. And they are residing on the conductor now. Over the conductor, charges can move. Conductors allow the charges to move. So when they repel and when they can move, they start moving away. And as they move away, they keep on repelling. And what is the maximum distance at which they can accommodate? That is the outside part of the conductor. And so they come outside. This is the maximum distance at which they can accommodate. You imagine there are 10 enemies. Put them in a room and watch them in a CC camera. Where they will be sitting? If they are enemies, definitely they won't be sitting in the center and playing cards. They will be sitting in the corners of the room. They try to move as far as apart possible. Suppose you put friends, of course they come closer. So here, these are all enemies. Electron repels another electron. So they repel each other. They come to the outside part. That is the maximum distance at which they can come. Sir, can't they go outside still? No, they have to leave the conductor. Outside it may be vacuum or it may be even air in general. Air is a poor conductor of electricity. It's an insulator. So thank God air is a poor conductor of electricity. Otherwise electricity would have flown even in air. So air is a poor conductor of electricity. Electrons can't go outside. So charges always reside on the outer surface of a conductor. It is only in conductor. What about in insulator, sir? In insulator, charges are localized. I will take a wooden ball. Say this is made up of wood. And I put some electrons here. They must remain there only. They are localized. They can't move. Of course, you will ask one question. Sir, won't electrons repel electrons now? Yeah, they repel. They repel each other, but they can't move. So the insulator doesn't allow the charges to move. So they can't move. So they stay there only, keep on repelling and stay there only. So in an insulator, charges are localized. And in a conductor, they come outside. And you have a beautiful example for this. What happens in our day-to-day life? You know, aeroplane moves in air, right? And it flows with a very high speed through air. And when an aeroplane, and you know that aeroplane body is made up of, it is made up of metal. And as it moves through air, there is a friction between air and that metal. So that continuous friction makes the body of the aeroplane charged. So this is a very interesting phenomenon. When the aeroplane flows with very high speed, its body gets charged. Say its body is negatively charged. I don't know exactly what is the charge over this. Say it is negatively charged. Say air molecules and that body of the aeroplane under friction makes it negatively charged. Sir, what about the passengers inside? Don't they get charged? No, because these negative charges keep on repelling and they come outside. They want to go as far apart as possible. So the maximum possibility is outside. Inside, passengers are very safe. They are very safe inside. But this causes problem when the aeroplane gets landed and the passenger starts getting down from the aeroplane. And if the aeroplane is landed on the wheels, and you will have a ladder type of arrangement here to get down. Now there are plenty of charges on the body of the aeroplane. And aeroplane has landed. Wheels are made up of non-conducting rubber or so. When it is landed, the charges are on the body. And if, suppose, there are very less chances of this accident happening. Suppose you touch the body of the aeroplane or this ladder, and if you touch the ground with bare foot, without any wearing without any chappals, then what happens is all these charges go to the ground through your body. And we have a concept called earthing. I will say what is earthing. All the charges flow through your body. Your body is a very good conductor to the ground. And you will feel a heavier shock, and that will damage your body. So how to avoid this? People have avoided this by using wheels which are not only made up of rubber or something non-conductor. It is also mixed with a small amount of metal. So wheels of the aeroplane are also made up of some conducting material, so that the body of the aeroplane is charged because of friction as it moves through the dry air, and as soon as it gets landed, this conducting material touches the ground and all the charges flow to the ground. So it is earth, and you are safe inside now, and even after landing the charges will not be there in the aeroplane, and you can get down very safely. So this method is very important. Charges always reside on the outer surface of the conductor. Now, if it is so, here you say, now we will come back to our job. We have left this already. Now, two conductors, A is already charged. I want to charge B. Method used is conduction. Very simple. These electrons are already repelling each other, and they try to move far apart as far as possible. They are in the outermost surface now. Further apart, they can't move. It is as if you are sitting in a room and there are 100 students in a small room. There is suffocation and you are feeling very difficult to sit in the class because there are a lot amount of students in the class. And suppose a door is opened in your classroom, and if you are given chance to go to the other classroom, definitely some of the students will go to the other classroom because they don't want to try to move away because this is not a very good environment. Will all the students go to the other classroom if it is of the same size, say? No, never. Because if all the students go to the other classroom, then the situation will be of the same here. So some of them will go away. Similarly, these electrons are finding a chance to move away, connect them by a wire. Immediately, or make them in contact. Immediately, some of the charges from here will go to the other conductor, and other conductor also gets charged. And since we have used conductors, charges can flow, and this wire should also be a conductor. Some of the charges will flow to the other conductor. This also gets charged. Sir, how much charge? That depends on the size of the other conductor. If both the conductors are equally sized, having the same radius, then the amount of charge will be shared between the two. If you have two beakers of the same size, one having water, one not having water, connect them by a pipe. Water gets flowing from one beaker. Water will flow from one beaker to another till the levels are equalized. And if the beakers are of the same size, definitely amount of water will be same. So equal amount of charges will be distributed in the two spherical conductors if they are of the same size. Otherwise, there is some other method of calculating. If this is of smaller size, how much charge will come to this? And if this is of larger size, how much charge will come to this? And that requires some other concepts to be studied. Okay, so this is the simplest way of charging a body. Take two conductors, connect them, and charges will flow from one body to another, and both of them get charged, and charges will be transferred. Oh, that is conduction. Only metals can be used for this method of charging. Okay. What do you mean by charging by induction? This is another one. Induction, in conduction process, we bring them in contact. Physically, we bring them in contact. Whereas in induction process, there is, and that word itself says, they are physically need not be brought in contact. I want to charge a conductor using another charged body. So I take two spherical conductors like this. I place them on an insulating stand, wooden stand for example, so that charges doesn't leak to the ground. I have not discussed earthing. I will say that what is earthing later. So these are wooden stands, two spherical conductors which are not charged. I am willing to charge them now, are kept in contact and kept over a wooden stand. Now I will bring a charged body here. Say this is positively charged body. Already this is charged. Simply bring it in very close to the two conductors. Now what happens? Since this is a conductor, both of them are conductors, they contain plenty of free electrons. And these free electrons, which are roaming around inside from atom to atom, they find that their friend has come here, they have been attracted here. So many of the electrons will get attracted here. So all the students will be running in a corridor and they are not attending class, not going to the library, simply moving here and there in the corridor. Suppose a very important person comes to the college. Suppose a film hero comes to the college and they get the news that a film hero has come and he is in the principal chamber. All the people will run to the principal chamber to see him and get the autograph. Electrons are the friends. Some of the electrons will be attracted towards this. So this end gets negatively charged. And we call this as induction. This is not conduction. So induced, this has not been in contact with this conductor. Simply I have brought it very close. Since this is positively charged, some of the electrons will get attracted. Conductors have plenty of free electrons. This can happen only in conductors. Electrons get accumulated in this end. So nearer end is induced with the negative charges. You can use this word. When a charged body is brought nearer a conductor, the nearer end is induced with opposite charges. What about the farther end, other end? These electrons might have lost their place from here somewhere. So there is a deficiency of electrons here. So there may be a positive charge here. So other end is induced with the same type of charges. This is positively charged body. Nearer end is induced with the negative charge. Farther end is induced with the a positive charge. Or nearer end with the opposite charge. Farther end with the same type of charge. Now, sir, whether the process is over? No, process is not over. Because if you take this charged body away, what happens? The charges, these electrons again come back and join with this and neutralize the body. Then how can you charge a body? Now what you have to do is separate them. With this charged body here only, keep this charged body, don't take it away, separate the two conductors. They should be still on the insulating stand. Bring them a little bit separated. Of course, now the negative charges are here and the positive charges are here. This is the deficiency. Positive charge in the sense, these electrons have gone here, so there is a deficiency of electrons here. There is a movement of electrons here. There is an excess here. So Now also the whole body is neutral. Of course, I have taken them away. Once the bodies are separated, take this away. Remember, anywhere we have not brought this in contact with the bodies. We have just brought it closer. So take this away. When you take this away, what happens is, there is no attraction now from this side. These electrons now feel that there is nobody here to attract them. So they try to go back to their original place. But they can't come. In between we have air, and that air is a poor conductor of electricity. Charges can't move through air. So they must remain here only. But there may be an attraction between these negative and positive charges. So they may accumulate here. And these positive deficiency may be occurring here. Now if you separate them far apart, keep them very much far away, what happens? And these, since both are conductors, you know that charges always get distributed on the outer surface of the conductor. So these negative charges get distributed here and outside at the farther apart place, and these positive charges get distributed far away. So now both the metals are charged. Originally you see these charges were taken and, these bodies were neutral. Now both of them have been charged. So this is the process of induction. Method of charging a conductor using the third process called induction. So in between, these are the three methods. So there may be many questions here. What is friction and which material can be charged by friction? Friction is a method of charging a body just by rubbing the two things against each other, and insulators can be charged by friction, not conductors. And mention the two methods of charging a conductor, conduction and induction, and explain induction. Of course, this is not a very important question, but still you must know how to do this, and only conductors can be charged by this process. Okay. Now, what do you mean by earthing? We'll go for that. Earthing is a very important factor in charges. Earth is a very good conductor of electricity. It's a very good conductor. And we show earthing usually by drawing three lines like this. One larger, another little shorter, another little shorter. That is a method of showing earthing electrically or in electronics or in physics. Now, Earth is a very, very large object. It can receive electrons. It can give away electrons as much as possible. Sir, I want, suppose you charge a body negatively, say, like this. Somebody have given electrons to this, and this is a conductor, say, and charges have been accumulated outside because they are repelling and they come outside. Now, this body says, sir, somebody have put electrons on my body and I have excess electrons. Please neutralize me. Please make number of protons and electrons equal. Let them be balanced. How to do that? You have to remove these free electrons. And who will receive this? Earth is ready to receive. Earth can receive electrons. And Earth can give away electrons also. Sir, if Earth receives electrons, does Earth get negatively charged? No. If Earth loses electrons, does it gain positive charge? No. Why it is so? Very simple. Earth is a very large object and its capacity of holding charges is very, very large compared to the ordinary objects that we use like a straw or a wool cloth or whatever it is. Earth is a very large object. And if you add few electrons to the Earth, it doesn't make any difference at all. And if you remove some electrons from the Earth, it doesn't make any difference. It is as if remove one bucket of water from the sea. Does the sea level go down? Never. That one bucket of water has nothing to do with the sea, and it is nothing in front of the sea water. And add one bucket of water to the sea. Will the sea level rise? No, never. It is nothing to the sea. If you deposit some 1,000 rupees to a bank, then the wealth of the bank will not increase by a large amount, and the bank manager need not have to think what to do with that money, because 1,000 rupees is nothing compared to the already available money in the bank. And if you take a loan of 1,000 rupees from the bank, will not be going for, or it will not lose anything. So it is a very small amount to that. But sir, then suppose if I rub the straw against my hands, the straw gets that one charge and the hands get another charge. Why it is so? Because the number of electrons transferred and the number of electrons already available, that is a comparable number. So if you deposit 1,000 rupees to a bank, for a bank it is nothing. Nothing will change in the whole transaction of the bank. But if you give that 1,000 rupees to a beggar, beggar will be very happy, because 1,000 rupees do so much in his life, because he has least amount of money. So he feels very happy, and every day when you go by that side, he gives a salute to you, and that makes a lot of difference. But 1,000 rupees doesn't make difference for a bank. It has huge amount of energy. Similarly, if you add electrons and if you remove electrons from Earth, charge of the Earth doesn't change. And we assume that Earth is, because Earth is a reference for us for everything. Earth is available everywhere and you can connect anybody to the Earth. So we assume, or conventionally we take that Earth is neutral. The charge of the Earth is neutral. So now suppose you have a negatively charged body here. If you connect it to the Earth, what happens? If you connect this to the Earth, Earth's job is to neutralize everything, because we take Earth as a reference neutral. Now these electrons flow from the body to the Earth. So electrons flow from the body to the Earth. Whereas if you charge a body positively, how do you charge a conductor positively? You know that a conductor is charged positively by removing electrons from it. We have to remove electrons. That means somebody might have taken electrons from this. There is a deficiency of electrons. This body will be always asking, make me neutral by just giving me some electrons. So if you connect a body to the Earth, positively charged body to the Earth, electrons flow from the Earth to the body and neutralize it. So this point should be very clear. Remember, we can't make protons to move from one place to another so easily by rubbing or any other method. So they are inside nucleus, tightly bound. Lot amount of energy is required to remove protons. So positive charges cannot be made to move. Only we have to request electrons. So when a negatively charged body is connected to the Earth, electrons flow from the body to the Earth. When a positively charged body is connected to the Earth, electrons flow from Earth to the body and neutralize this. Sir, for example here, electrons flow from body to the Earth. Till what instant it will happen? Till all the excess electrons reach the Earth. Sir, won't the Earth attract or receive extra electrons from the, some more extra electrons from the metal? Suppose there are 10 electrons, say 100 electrons in this excess. After those 100 electrons move to the ground, won't some extra electrons, some tiny electrons will move to the ground? No, that is not possible. Once the equilibrium is reached, the flow stops. Suppose you have two beakers, one containing more water and another containing less water, connect them by a pipe. Water will start flowing from high pressure beaker to the low pressure beaker till the pressures are same, levels are same, pressure levels are same, and then the flow stops. Once the equilibrium is reached, you can't expect the water to flow further. Flow stops. So once we treat Earth as a neutral body for our reference, and once the neutrality is reached here also, flow stops. So the electrons which are required to neutralize all these positive charges will flow. Once the body is neutralized, the flow stops and the body gets neutralized. So if you want to convert a charged body to a neutral body, connect them to Earth. Second point, when a negatively charged body is connected to the Earth, charges will flow from the body to the Earth, and when a positively charged body is connected to the Earth, electrons flow from Earth to the body. So this is one thing, and we use this earthing in our day-to-day life. If you go home and see the electrical connections in your house, you see that one wire, you have three holes in the plug, and one is called ground, earthing. One wire is always connected from that hole to the earth. And while we are having electrical connection, you might have seen in new houses, they dig the earth and make some gap in, make some space, and they put some salt, charcoal, and anything, some other thing, and a very good copper rod, which is a conductor, and connect it to this that earthing wire. Why it is done? Because whenever you connect an instrument like grinder or iron box to the earthing, to the plug, one of the wire connected to the earth is connected also to the body of the instrument. Iron box body, it is made up of metal. Even the grinder, that body is metal at some parts, and that part is connected to a wire and it is connected to the earth. Because if there are some stray charges, or if there is some loose connection inside the iron box, and some phase wire, some electricity wire is connected to the body of the instrument, and when you are using iron box, suppose your fingers get in touch with the body of the instrument, then the charges flow, that extra charges with the body will flow through your body and to the ground. It will be earth connected. So it will give you a heavy shock to your body. So how to avoid this? already, the body of the instrument is connected through a wire to the earth. So all the charges, if there is any leakage, all the charges will have already flown to the earth, so you are safe. So earthing wire in houses, and it safeguards the human beings, and it protects our body if there is any leakage of charges or leakage of current. So that is very much needed. And even the tall buildings will have lightning arresters. You might have seen lightning arresters like this, very sharp objects like this. Three or four sharp metal pieces will be connected to a rod, and that will be held at the top of the building. Why? Because clouds contain lot amount of charges. Clouds get charged because of the friction between the molecules. There are many reasons behind the clouds getting charged. And when these charges are accumulated larger in number, the charges from one cloud may move to the another cloud. So that shows lightning in the sky. That is one type of lightning, when the charges move from one cloud to another. The second type of lightning is these charges, after getting accumulated to a large amount, they can't bear it so much, and they flow to the ground through air. Even air acts like a conductor. You will study that later, why air is a good insulator, but even then it conducts the charges, gives a path to the charges to the flow, charges flowing to the earth. So that is what you call lightning. Now during that lightning, these charges will be flowing with high amount of energy. They may show that energy in the form of kinetic energy, heat energy, light energy, sound energy, and so on. And that energy is so huge that if it comes across some buildings, some trees, or some living beings, it will destroy everything, because that energy is in a huge amount, large amount. So we don't want that lightning to happen in the region where there are habitants, there are people. So how to remove those charges easily and make them to flow to the ground? Give them the easiest path. Suppose you have a building, very tall building. Of course, this is not geometrically of the same size. Of course, you will have a very small lightning arrestor. So this is called lightning arrestor. It contains very sharp ends. Suppose a cloud passes by, which is charged, passes by the side of the this lightning arrestor. This is made up of metal. Sharp objects always attract charges, and these charges will flow to these sharp objects, and this is always connected to the earth through a very thick metal strip, copper strip, and these charges easily flow to the earth, so that they do not float to the air and damage the things which they come across. So lightning arresters protect the buildings by discharging all the charges in the clouds and sending them to the earth. So it is not safe to touch those wires, earthing wires, in a building or in our house while it is lightning. It is very dangerous. Or even in the other days, better not to touch them, because they will be carrying all the straight charges to the earth. So earthing is very important for us. Okay. So earthing makes the charges to flow to the earth, but a charge of the earth doesn't change, because earth is a huge body. It can receive and it can give away any number of electrons, and still it remains neutral. Okay.